Hello, in this video, I explained the relationship between correlation coefficient and regression R squared. Normally in a correlation matrix, we want to avoid correlation values that are greater than 0.7, for example, because they raise the issue of multicollinearity. So let's say that we want to look into the relationship between marriage and divorce, okay? And we are interested in that. So then we will observe the correlation matrix, which is 0.9349, which is quite high. So we don't want to have that. But the main issue under in this video is to see how is this value related to the regression between these two variables. So in a simple regression where we have one regressor or one independent variable, the R squared should be equal to the square of the correlation value. And so if the square of the correlation value explain that, so it's in a way telling us about multicollinearity problem. And values greater than 0.7, as we know, is a big problem. But now we are going to Stata to show how the two are related. So let's go to Stata, and then we can look for example data sets in Stata. So let's go to dataset install with Stata, and the one I use is census.dta. So I'll simply click on use, and that should load the data and say 1980 census data by state. So now I want to see the correlation matrix for the variables. So here we see that the variables, if you are not interested in one particular variables, just type all. You get correlation matrix for all. So core will give us correlation matrix for all, just like I did. Now, but we are interested in these two. I could have just typed core, and then I'll look for these two variables, marriage and divorce. Okay, so we have again the same value. Now the square of this value should be equal to the R squared in the simple regression. So let's get the square of that. So as we remember in Stata, we can use this as a calculator. Display this value multiplied by itself will give us the expected R square. So the R square here is 0.8743 and so on. So we will see this in a regression between just these two variables. So if I say regress, so then I pick one of them as the dependent variable and the other one is the independent variable. So then I look at the R squared, which is 0.8740, which is the same as what we found here, the square of the correlation coefficient. So you see that they are quite related, or they are the same. So what does that mean? It says that divorce explains up to 87% of the variation in marriage. That is quite high, and that rings the bell of multicollinearity. So how do we check for multicollinearity? So then let's run a regression where these two variables are regressors. So let's say regress, and then let's say that we are interested in median age as the dependent variable, and then include these two variables as regressors, okay? So we run, and then after that, we're simply interested in the VIF score. So you say stat, VIF, then we get the scores. So you see they are greater than 0.5, and that is a problem. Greater than 5. When the VIF value is greater than 5, then there's an issue of multicollinearity. So, and that was also already illustrated by the correlation coefficient value, which was higher than 0.7. Okay, so this is how we illustrate the link between regression R squared and the correlation value between two variables. Thank you for watching, and I'll hope to see you in the next video.